Section 11.1 is a lot of review. It's stuff we talked about in Chapter 4, but since we haven't talked about solutions in a while, let's make sure that we understand all of these concepts because this will be really important for the next several chapters. So when we talk about a solution, there are three words that we're going to use a lot. The first one is solute. Now the solute is the stuff that is being dissolved. So for example, if I was looking at salt water, the salt is being dissolved, it is my solute. The solvent is the stuff that is doing the dissolving. So again, if I'm looking at salt water, the water, it is what is dissolving the salt, so it is my solvent. The solution is my homogeneous mixture. Remember, homogeneous is the same throughout, so it's going to have the same properties from the top to the bottom, same melting point, boiling point, same concentration, everything's the same throughout. Now, we are looking at mixtures, and mixtures can have variable composition, so it's not always the same amount of stuff that's dissolved in the same amount of solvent. So we need to know the amounts of substance in our solution. Now we can talk about these two different ways. The first way is qualitatively. If I'm talking about a solution qualitatively, I'm going to use the words dilute or concentrated. If I say that a solution is dilute, there's relatively little solute in my solution. It's mostly solvent, so I dissolve just a little bit of stuff in there. If I say it's concentrated, there are going to be large amounts of solute in my solution. So qualitatively, I know that there's a lot of stuff in my solution if I say it's concentrated, but I don't know how much. So if I want to describe it quantitatively, there are several terms that we talked about in previous chapters. So let's review those quantitative terms. Now the one that we will be using the most is molarity. If I use the term molarity, molarity is moles of solute per liter of solution. When we talk about molarity, usually we don't write moles per liter. When you see units, it's usually written as a capital M. And when I write my capital M so that I know it's a capital M versus a lowercase, because we use lowercase for other things, I underline my M so that I know it's a capital. Okay? So molarity is moles of solute per liter of solution. Mass percent is my mass of solute divided by my mass of solution. And because this is a percent, I need to multiply my answer by 100. Now, because I'm looking for mass percent, when I have units of this, it's going to be in terms of percent, but it's going to be percent of my solute. So if I was looking at salt water, I would say my solution was, for example, 37% NaCl. So I'm talking about how much of my solute is dissolved. When we look at mole fraction is going to be represented by this funny little X. It's a Greek symbol. It's actually called chi. Now when you see the formula for this, you'll see the X with the formula for whatever compound or element we're looking at next to it. That's going to be equal to N times that compound, or sorry, N of that compound. Now when we say N, if you think back to gas laws, it's the number of moles. So it would be the number of moles of that specific substance I'm looking at. Then it would be moles of that compound in the denominator plus moles of my solvent. So this is my total moles. If I have a mixture with more than two things, then I would have to have moles for everything on the bottom. Okay, so this is just moles of the substance you're looking at divided by the total number of moles in your mixture. Now, because I'm going to be dividing moles by moles, this one has no units. In mole fraction, the units are going to cancel out. The last term that we're going to talk about is molality. Now be very, very careful. Molarity is a capital M. Capital M molarity is moles of solute per liter of solution. Molality is lowercase m. Molality is moles of solute. So it starts out the exact same way, but this time it's kilograms of solvent. Okay, so be careful. Molarity, moles of solute per liter of solution. Molality, moles of solute per kilograms of solvent. Now, instead of writing moles per kilogram, when you do units, you'll usually see the lowercase m, and that's why I underline my big M, so that I know whether I'm talking about molarity or molality, because my M's look very similar if I don't distinguish, but they're very different. So when we talk about these two, I would say that I have, if I was talking about molarity, a 1 molar solution. If I'm talking about molality, I would say I have a 1 molol solution. So make sure that you know the difference between the two. So here we've got an example, so we can take a few minutes to practice these calculations that we should be pretty familiar with. So I've got a solution. I'm mixing 1 gram of ethanol. So this is my solute with 100 grams of water. This is my solvent. The easiest way to tell the difference between a solute and a solvent is look at your masses. Whichever one is smaller, it's going to be dissolved. So I'm getting a final volume of 101 milliliters. This is my solution. So take a second and calculate the molarity for this mixture. Remember, you're solving for capital M. Now take a second and calculate mass percent. Remember, mass percent is the mass of your solute per mass of solution. Calculate the mole fraction for your mixture. Mole fraction is going to be moles of your ethanol per total moles of your solution. And remember, we don't have units for this. Now take a moment, calculate molality, lowercase m. So moles of solute per kilogram of solvent. These terms will be very important in all of our later chapters. When we talk about acid-base, oxidation reduction, kinetics, equilibrium, all of these chapters we're going to be working with solutions. And so we're going to need to know the concentrations of our solutions for all of our reactions. Again, molarity is the most important, but we need to know all of these terms.